So I'm showing you the possibility of what we're going to do once we overload the cout. So I'm almost doing this backwards. I'm not showing you the code to construct this yet, but I'm showing you the code to finish this and to make sure that it works. Overloading the cout function is just that, and I'll go over a quick thing of overloading here in the next slide, or maybe before, I forget which one, but bear with me here. The old way of doing this is going to do a cout for every single data member in our structs or instances of our structs. And that's fine. There's nothing wrong with that. But as the structs get bigger and stuff like that, it's going to start to suck. We talked about that. Okay? So there's nothing wrong with what we have here. But how's that working out? And you're going to hear me say old cout and new cout. This old way is using the old cout. The old cout is great for simple data types. But you're saying, wait a minute, but this is not a simple data type. It is a newly custom complex data type that we call date. Well, that's true, but notice I'm specifying every single member from that instance. Month is an integer. Day is an integer. And year is an integer. So the old, yeah, that's my walking stick. This should be interesting to put in the video. My old walking stick here, cout can take, the old cout can take care of that, no problem. But what I'm hoping to do is instead of having 3 lines or more for every single instance, I'm going to try to cut it down to 1. Now here's the problem, is that Lupoli or Ryan, they are of a complex data type. So I'm going to have to create a new cout function that will handle complex data types. Now the good news is that it's a template. You can change it slightly, get the darn thing to work, and that's it. And I'll go over the code here in a minute. But again, that's the difference between what's happening with couts, is that if we're doing a normal variable, the computer's going to look at cout and says, ooh, I got 2 of them. I've got one that's going to be the old one from IOStream that we always include, or the other one's going to be our new cout that has date in it. Okay, which one is X? Is X the old style int, float, double, or is it the date? Well, we know that X is of an integer type, so it's going to use the old cout in order to display that value. That's really what's happening behind the scenes when we're overloading. Think about it this way. We have date Lupoli, nothing crazy there. We have cout Lupoli, so we know that we're calling cout. We don't know which one yet. Then we get to Lupoli. Is Lupoli an integer variable or double or flip? Nope. Is it a date? Yes. So cout, the compiler's going behind it going, okay, which one is this? Is it a new cout or is it the old cout? And this one's using the new cout, so that's how we're using overloaded of couts in order to display our complex data types, frankly, easier on us in the long run when it comes to coding. Setting up is interesting. I'm not going to lie to that, and that's what we're going to talk about next.